Good evening, everyone. I'm Anushka Shukla, and today we're diving into the mechanics of modern data world, the functional view of the big data ecosystem. Big data is no longer a futuristic concept. It is the fuel powering every single major organization today. It's not just about collecting information, it's about having a systematic pipeline to transform immense amounts of data into concrete business decisions. Over the next few minutes, we will walk through the five critical layers that make this transformation possible and make the whole view of the big data ecosystem. Before exploring the layers, let's nail down what we mean by big data. It's a common misconception that it's purely about size or volume. While data sets are indeed massive, big data actually describes any data sets that's too large, too complex, or moving too fast for traditional database. This shift is fundamental. Today, data pours in from countless sources: customer transactions, application logs, social media, IoT sensors, etc. This diversity and speed is where the V's come in. The volume, which basically means the massive amount of data we have. Velocity, the high speed at which data is generated and must be processed. Variety, data comes in every imaginable format: structured, semi structured, or completely unstructured. Veracity, this is very crucial. It's about ensuring the quality, accuracy, and trustworthiness of your data before you make a $1 billion decision. And finally, the most important, value. The entire point of building this complex system is to extract actionable business intelligence and opportunities from the noise. A modern big data ecosystem is built on a continuous pipeline of five interconnected functional layers. The flow is very logical. The raw data enters, is stored, transformed, analyzed for insights, and finally delivered to the user to drive action. Let's quickly outline these five steps. Ingestion, crucial entry point for collection of raw data. Storage, providing the scalable and durable repositories to hold the data. Processing, the engine that cleans, transforms, enriches the raw data. Analysis, where data scientists and analysts apply statistical models and machine learning to find patterns. Visualization and application. The final step, delivering the insights in a clear and actionable format. Now let's learn about all the layers, forming a complete value chain. Layer 1, data ingestion, is the gateway to our entire data ecosystem. Its purpose is to efficiently and reliably collect information from every producer, whether it is APIs, IoT devices, or traditional databases. It acts as the source of necessary bridge between the data sources and the analytical infrastructure. The main challenge is managing different speeds of data, where generally we categorize them into two types: batch ingestion and real-time streaming. Batch ingestion means it processes data in scheduled intervals, and real-time streaming means it captures the data moment it's generated, like liver sensor readings. It is essential for immediate insights, such as fraud detection or operational monitoring. It requires an instant response. Once ingested, data needs a scalable home. Layer 2, data storage, provides the foundational architecture for the entire system. The two primary architectures are data lake and data warehouse. A data lake is a massive central repository that stores raw data in its native format. It offers incredible flexibility, accommodating any data format. It operates on a schema on read model, meaning you define the structure only when you need to read or analyze the data, and it's very cost effective. In contrast, a data warehouse is highly structured and curated. It uses a schema on write model where you must define the structure before the data is loaded. It is actually optimized for fast, complex queries on clean and structured data sets. It is the go-to architecture for business intelligence and standard reporting. In terms of cloud storage platforms like AWS, Google Cloud Storage, they offer unlimited scale. For on-premise solution, the HDFC Hadoop distributed file system provides a fault-tolerant distribution storage. Layer 3 data processing. It is the transformation engine. This is where magic happens and raw data truly becomes useful. It performs essential tasks like cleaning messy data, aggregating metrics and transforming data, enriching records by combining them with external context, and applying core business logic to create curated data sets. It is similar to the ingestion. Processing is also split into two main paradigms: batch processing and stream processing. Batch processing handles large scale transformation on historical data, ideal for complex ETL, and stream processing operates on data in motion with sub-second latency. It powers real-time dashboards, recommendation engines, and high-speed operational monitoring. The dominant technology here is Apache Spark. Spark is the unified engine that can support both batch and streaming workloads. Layer 4, data analysis. It is where we finally extract intelligence from information. This layer represents the fusion of human expertise, analysts, and scientists with immense computational power. Key capabilities of this layer include interactive SQL queries, machine learning, statistical modeling, and exploratory analysis. For the tools that power these tasks, Apache Spark ML Lab provides distributed machine learning algorithms that scale to billions of records. The final layer, visualization and application. It is all about delivering value to the decision makers. If an insight cannot be understood and acted upon, it is useless. Hence, this layer is very crucial. There are two ways to this information is delivered. Business intelligence dashboards. These interactive dashboards provide at a glance visibility into KPIs, trends, and performance metrics. They allow non technical users to drill down, filter, and explore the data themselves. Custom applications. This is where the intelligence is baked directly into operational systems. Think of recommendation engines on e commerce sites, personalized features in a streaming app, or intelligent automation systems. Visualization is the layer that completes the value loop, turning abstract data into tangible business results. It is important to realize these five layers are not a one time linear process. They form a continuous value chain which completely shows us the ecosystem of the view of the whole ecosystem. The ecosystem is dynamic. Insights from visualization may expose a new data gap that drives new ingestion. An observation during analysis may reveal necessary processing. The continuous feedback loop is what creates a true learning organization. By constantly evolving the process, the organization becomes more intelligent over time, adapting to changing business conditions and consistently uncovering new opportunities. Slide 10. Next step. So, with this function framework and view in mind of a big data ecosystem, how can we actually build our own big data strategy? So, we need the four key steps, which are define business objectives. We should always start with the problem, not with the technology, and the technology choices must support the business goals and not the other way around. We should prioritize scalability. We must design for the future, not just today. The rule of thumb is to plan for 10x growth, ensure interoperability, choose the tools that work together seamlessly, rely on open standards and APIs to prevent the vendor lock-in and allow you to use best tool for each specific job. Build organizational capability. Technology is only half the battle. You must invest in training your team, establish strong data and governance policies, making your organization foster a culture of data-driven decision across the entire organization. The big data ecosystem is complex, but by understanding this view, ingestion, storage, processing, analysis, and visualization, you have the map to transform raw data into continuous source of competitive advantage. Thank you.